friends, this is Javed Shaikh, a mathematics faculty at T.I.M.E here. Today I'm going to discuss with you all the immensely useful tips for cracking trigonometric proofs. Now, I have usually seen students, they do not understand, when they come across a trigonometric proof to solve, they do not know how to proceed. So in that case, these tips will be extremely useful for you all when you are sitting for your final board exam and when you are under stress. Now let's see what are the tips. The first tip that we will use is always start from the complicated looking side first. You have LHS and RHS in the trigonometric proofs. So you can start with the either LHS or RHS. It is not mandatory that you have to start with LHS and then prove that it is equal to the RHS. So you can start from RHS and then prove that it is equal to the LHS also. Now the second one is change all the trigonometric functions to sine and cos wherever required, and this is to be applied in more than 90% of the proofs. Now in most of the cases we get trigonometric proofs or trigonometric identities wherein there are other functions, trigonometric functions apart from sine and cos, like tan, cot, sec, cosec. So what you have to do is first change those to sine and cos and then proceed. So it becomes very easy to crack the proofs or solve the proofs. And in the 90% of the proofs, you will find this applicable. This has to be applied in more than 90% of the proofs. Now next is memorize all the Pythagorean identities and make judicious use of these identities. Now you have these three Pythagorean identities: sine square x plus cos square x is equal to 1, 1 plus tan square x is equal to sec square x, and 1 plus cot square x is equal to cosec square x. So apply these Pythagorean identities and apply them judiciously. Wherever required, you have to think and apply them judiciously. Okay, coming to the fourth tip. If there are binomials in the numerator and denominator consisting sine or cos function, such as 1 plus sine x, 1 plus cos x, etc., then rationalize if required. Now you know what is rationalization. So rationalize if required, especially if they are under the root sign like this. And rationalization has to be done within the root sign itself. Coming to the fifth point, while working, if you get stuck up somewhere, then try to get common denominator and combine the terms. Like what you should do is you should either multiply and divide with some particular function and then try to get the common denominator and then combine the terms so that you can either add or subtract the numerators and with the same denominator. Coming to the sixth tip, it is make use of following identities whenever required. Now you all are very well versed with these identities. You all have studied these identities in your 8th and 9th standard. So you can use these identities, which is a plus b whole square, that is a square plus 2ab plus b square, a minus b whole square, that is a square minus 2ab plus b square, a square minus b square is a plus b into a minus b, a cube plus b cube is equal to a plus b into a square minus ab plus b square, a cube minus b cube is a minus b into a square plus ab plus b square, a plus b whole cube is a cube plus b cube plus 3ab into a plus b. The final one is a minus b whole cube is equal to a cube minus b cube minus 3ab into a minus b. Okay, now let us see how these tips can be applied with an example. Now the example is tan a upon 1 minus cot a plus cot a upon 1 minus tan a is equal to 1 plus tan a cot a. Now here what you have to see is which side is the complicated looking side. Now here you can easily see that the left hand side is a complicated looking side. So we can take this first and prove that it is equal to RHS. It is not mandatory that you have to start with the LHS. If you see that the complicated looking side is on the right hand side, RHS, then you take that first, RHS equal to that, and prove that it is equal to the LHS. Now here, this side is the complicated looking side. So we have taken this side, and now the next, what we are applying is the next step, that is change all functions to sine and cos, your second tip. Now this can be applied like this. You have to change all these functions to sine and cos. So tan a can be written as sine a by cos a. 1 minus cot a. Cot a can be written as cos a upon sine a. Plus the same thing here. Cot a is written as cos a upon sine a divided by 1 minus sine a upon cos a. Now we'll take the LCM of the denominator. As you can see, we have taken the LCM. which is sine A, and then we have got the numerator as sine A minus cos A. And the same thing we have done on this side. Cos A is the LCM, and then we have made cos A minus sine A in the numerator. Now the next step would be, we will take this denominator, which is the denominator below sine A upon cos A. Now this denominator, when taken in the numerator, will get reciprocated. I mean, we will take the reciprocal of this and write it like this: sine A upon sine A minus cos A, this remaining the same, and here also plus cos A upon sine A remaining the same, multiplied by cos A gets in the numerator cos A divided by cos A minus sine A. Now the next step is, we can see sine A into sine A, sine square A, divided by cos A into sine A minus cos A, plus cos A into cos A is cos square A, sine A divided by sine A into cos A minus sine A. Now what we have done is, to get a common denominator, a part of the denominator can be made common over here. So what I have done is, I have interchanged the places. I have made this sine A minus cos A and replaced it this plus sign with a negative sign here. So this becomes sine square A divided by cos A into sine A minus cos A, minus cos square A upon sine A into sine A minus cos A. So now you can see that part of the denominator is common now. Now what we have to do is, we have to make the entire denominator common in both the terms. Okay. Now when you feel that you don't know how to proceed, when you feel that you are getting stuck up somewhere like this, what we have to do is, we can use this particular tip now. Take or multiply and divide this particular term in such a way that we will get the common denominator completely. Now here what we have done is, we have multiplied it by sine upon sine, multiplied and divided by sine and sine, and this side cos and cos, so that the denominator becomes common. As you can see, we have made the denominator as sine A cos A into sine A minus cos A. Here also the denominator becomes sine A cos A into cos A, sine A minus cos A. So now proceeding further, what we can say is, sine A into sine square A sine cube A divided by sine A cos A minus multiplied by sine A minus cos A, minus cos cube A divided by sine A cos A into sine A minus cos A. Now you can see that the denominators are common. So we can combine the terms, get the numerator like this: sine cube A minus cos cube A divided by sine A cos A into sine A minus cos A. So now we can make use of this identity. Now this tip we can apply, which is the sixth tip. A cube minus B cube equal to A minus B into A square plus AB plus B square. As you have seen that we have sine cube A minus cos cube A in the numerator. So we are applying this particular tip. Now we are applying this identity, and we are obtaining sine A minus cos A. According to this, sine cube A minus cos cube A is changed to sine A minus cos A into sine square A plus sine A cos A plus cos square A. And the denominator is sine A cos A into sine A minus cos A. Now we can easily see that we can cancel these two terms out, and we get 1 plus sine A cos A upon sine A cos A. Now splitting the terms, 1 upon sine A cos A plus sine A cos A upon sine A cos A. So we get finally 1 upon sine A cos A plus 1. So now we have obtained 1 plus 1 upon sine A cos A. So now we can use this particular tip, make judicious use of the Pythagorean identity. Now we know that 1 can be written as sine square A plus cos square A. As you know, the Pythagorean identities are sine square A plus cos square A is equal to 1. So we can apply this particular identity here, and we can write 1 as sine square A plus cos square A, because what you should do is, you should look at your right hand side and see what you want on the right hand side. Now on the right hand side, we need 1 plus tan A plus cot A. So tan A and cot A they are the ratios of sine and cos. Like tan A can be written as sine upon cos, and cot A can be written as cos upon sine. So here, changing this to sine square A plus cos square A. Now what we can say is, we can split the terms and write it like this: 1 plus sine square A upon sine A cos A plus cos square A upon sine A cos A. Now here, this is again written as 1 plus sine A into sine A divided by sine A cos A plus cos A into cos A divided by sine A cos A. Now 1 sine gets cancelled out. Here 1 cos gets cancelled out. So now we have 1 plus sine A upon cos A plus cos A upon sine A after cancellation. So this changes to 1 plus tan A plus cot A, which is our right hand side. And the proof is done. So now friends, you have seen how these tips come handy when you're studying for your final exams and when you're writing or when you're trying to crack the proofs. So start using these tips for cracking the proofs and do well in your exams. All the best.